chunk of the cliffside along an iconic Santa Cruz roadway. It fell into the ocean over the weekend as strong waves pounded the coast. West Cliff Drive has been a victim of relentless erosion over the years.
California's coastline is disappearing, not slowly, not over centuries, but in moments. On February 27, 2026, entire sections of coastal bluffs along the central California shoreline gave way without warning, dropping hundreds of feet of land into the Pacific Ocean in less than half a minute. Homes vanished, roadways fractured, clifftop trails simply ended in open air. And the question scientists are now asking isn't just how did this happen? It's what happens next. This is the story of the day California's coast let go. At 5:43 a.m. Pacific Standard Time, monitoring instruments operated by the California Geological Survey detected abnormal ground movement north of Pacifica. The readings weren't subtle. They weren't gradual. They were immediate red flags. Data streamed into the California Department of Conservation headquarters in Sacramento, where engineers stared at numbers that exceeded every modeled stability threshold. Phones were lifted before confirmation analysis even finished. By 5:51 a.m., confirmation came in the most violent way possible. A 240-foot-wide section of coastal bluff collapsed directly into the Pacific Ocean. Not in stages, not in chunks. In one continuous, catastrophic movement that lasted less than 20 seconds. Witnesses described the sound as thunder colliding with a freight train. The ground didn't crack slowly. It simply disappeared. 3 homes that had stood safely on certified land the night before were gone. By 6:17 a.m., a second collapse struck near Daly City. Another 180 feet of bluff sheared off the continent. A coastal walking trail used daily by thousands now stopped abruptly at open sky. A 70-foot drop to shattered rock and churning surf. Emergency alerts activated across San Mateo County, but the coast didn't wait for protocol. At 6:44 a.m., another section failed near Moss Beach. At 7:02 a.m., movement was detected near Half Moon Bay. By 7:30 in the morning, stress fractures appeared along 6 sections of California Highway 1, one of the most iconic coastal roads in America. By 8 a.m., officials confirmed what no one wanted to say out loud. 17 major collapse events. 41 miles of coastline closed. 11 residential structures destroyed or critically compromised. More than 430 residents under mandatory evacuation, and the ground was still moving. To understand why this happened, you have to understand what California's coastal bluffs really are. They look solid, towering, permanent, but they aren't granite cliffs carved from bedrock. The bluffs stretching across San Mateo, Santa Cruz, and Marin counties are primarily sedimentary formations, mudstone, sandstone, and ancient marine deposits compressed over millions of years. From above, they appear stable. Beneath the surface, they are vulnerable. Every wave that hits their base removes microscopic fragments. Every winter storm chips away at their foundation. Over decades, erosion undercuts the cliff face. But wave erosion alone didn't cause February 27th. This was something more. In January and February 2026, California endured a relentless series of atmospheric rivers, massive moisture-laden storm systems that delivered record-breaking rainfall totals across the Central Coast. Soil saturation levels reached 400% above stable threshold capacity in certain monitored zones. 400%. At that level, soil no longer behaves like solid earth. It behaves like a liquid held loosely in place by surface tension and friction. Then groundwater added another layer of instability. For 3 consecutive years, underground water tables along the Central Coast had been rising. Clay-rich layers beneath the bluffs prevented proper drainage, trapping moisture beneath the formations. Water pressure built from below, while storms saturated from above. The bluffs were squeezed in a geological vice. Wave erosion from the front, water saturation from the top, hydrostatic pressure from beneath. Physics doesn't negotiate. Eventually, it wins. At the United States Geological Survey offices in Menlo Park, scientists had been watching troubling indicators for weeks. Ground deformation sensors detected lateral movement drift of nearly an inch per day across a 12-mile section of coastline. That's not erosion, that's mass movement. Poor water pressure readings, which measure water force trapped between soil particles, exceeded critical failure thresholds by a factor of 3. Dr. James Vasquez at University of California, Santa Cruz later summarized the event bluntly. This wasn't one cause. It was every stress factor arriving at once. Wave energy, saturation, groundwater pressure, reduced cohesion in mudstone layers, sea level rise. Individually, these factors are manageable. Together, they form collapse conditions. And what terrified researchers most? The instruments didn't show stabilization after the collapses. They showed continued movement. The event may not have been the peak. It may have been the beginning. For residents, the science became personal in seconds. Families who had lived on those bluffs for decades watched their homes fall into the ocean via live stream footage from security cameras. Evacuation shelters across San Mateo and Santa Cruz counties filled rapidly. People arrived with medications, pets, documents, whatever they grabbed in the dark. But it wasn't just homes. Infrastructure began failing in quiet, dangerous ways. Sections of Highway 1 looked perfectly intact. Smooth pavement, clean lines, but the ground beneath had shifted laterally beyond safe load capacity. Engineers described vehicles driving on shelves of earth, preparing to detach. By 10:30 a.m., Highway 1 closed between Pacifica and Santa Cruz. Nearly 47,000 daily vehicle trips were rerouted inland. Utility systems were next. Pacific Gas and Electric Company reported transmission infrastructure compromise in multiple coastal zones. A gas distribution line near Moss Beach required emergency shutdown after ground displacement exceeded safe parameters. Tens of thousands lost service. Fiber optic communication lines buried within bluff formations snapped as earth shifted. Cell towers required structural reassessment. Emergency managers briefly lost reliable communication in active collapse zones. The coast wasn't just breaking, it was disconnecting. By midday, a new fear emerged. Was this localized, or was it statewide? Monitoring networks stretch from the Oregon border to Mexico. The same atmospheric river systems that soaked San Mateo County drenched nearly the entire California coast. Sea level along the central coast has risen approximately 3.4 inches since 2000. That sounds minor, but in coastal dynamics, a few inches changes everything. It shifts wave impact zones upward. It increases hydrostatic pressure at bluff bases. It exposes layers previously reached only during major storm surges. Elevated groundwater levels were measurable from Mendocino County down to Santa Barbara County. Sedimentary bluffs across that corridor share similar geology. By 11:45 a.m., USGS officials recommended precautionary evacuation assessments for structures within 200 feet of bluff edges across approximately 230 miles of coastline. Property value at risk exceeded $80 billion. Thousands of homes fell within the elevated risk corridor. This had the potential to become the largest non-hurricane coastal displacement event in American history. What makes this event particularly sobering is this. It wasn't unforeseen. Reports published in 2022 and 2024 identified California's coastal bluffs as critically vulnerable to the convergence of sea level rise, atmospheric river intensification, and groundwater saturation. Recommendations included expanded buffer zones, increased monitoring, and strategic retreat from high-risk zones. But development pressures continued. Coastal living remained desirable. Planning moved slower than climate acceleration. And then, February 27th happened. The most uncomfortable conversations are happening quietly now. Which sections of coastline can realistically be stabilized? Which cannot? Can infrastructure built on sedimentary formations withstand increasingly frequent extreme weather events? Can insurance markets continue underwriting properties in active geological risk zones? Can communities rebuild, knowing the same forces remain in motion? Because this wasn't just weather, it was structural change. Atmospheric rivers are projected to intensify further. Groundwater tables may remain elevated. Sea levels will continue rising. The bluffs that stood for thousands of years endured storms, droughts, earthquakes, and 10,000 tides. They did not fail because they were weak. They failed because the environmental system that stabilized them has changed slowly. Then, all at once, 1 week after February 27th, emergency response teams will still be working. 1 month later, insurance battles will begin. 1 year later, rebuilding decisions will divide communities. But the coastline itself, it will never look the same. The California California coast of the 20th century is not the coast of the 21st. The bluffs told that story the only way geology can, not through warnings, but through collapse. 200 feet of land, 20 seconds. A reminder that nature doesn't adjust to human timelines. It follows physics. If you found this breakdown informative, make sure to like this video. It helps more people understand what's unfolding along our coastlines. Subscribe for deeper investigations into the forces reshaping our world. And tell us in the comments, should California invest billions in stabilizing these bluffs? Or is managed retreat the only realistic future? The coast is changing. The question is, are we ready to change with it?